Hi, so today we're going to be learning topic 1.1. The goals are to use the order of operations to evaluate expressions and to also use formulas. We're going to begin with some vocabulary. So our first vocabulary is variables, which are usually in algebra your symbols or letters that represent numbers. So if you remember from algebra 1, the letters or variables we use the most are like x, y, and z. Algebraic expressions contain at least a variable. So an example of an expression would be like 2x minus 3 because it has the variable x, numbers, and operations. I just want to note that an expression can't have an equal sign. If there's an equal sign, that makes it an equation, not an expression. For this lesson, we're going to be using your order of operations a lot, or your PEMDAS. Now notice I have this written going down just so that you know the order. You always start by making your parentheses as small as possible. Then you move on to your exponents. Remember, when you have exponents, if you have like 5 to the third power, that doesn't mean you're doing 5 times 3. It means you're doing 5 times itself 3 times. Next, you would multiply and divide. I have those on the same line because you don't necessarily do multiplication first. It depends what comes in order from left to right. So for example, if you were to have 12 divided by 4 times 2, you're not going to do 4 times 2 first. You're actually going to do 12 divided by 4. So when you're multiplying and dividing, you go in order from left to right, whatever you see first. Same thing with addition and subtraction. Let's move on to some examples. So here, our first example, we're going to evaluate m plus p minus 1 squared. Anytime you see the word evaluate, that means to plug in a number for your variable and simplify. So for this particular problem, we're going to plug in 3 everywhere we see an m and negative 4 anywhere we see a p. So you can rewrite the problem using those numbers. From there, we're going to use PEMDAS to simplify. So we would start with our parentheses. So we're going to make this smaller. Negative 4 minus 1 is negative 5. Then we move on to exponents. So negative 5 squared means we're doing negative 5 times negative 5, which is 25. So you write down 25 and then you bring down the plus 3. At the end, when you add, you get 28 as your answer. This next problem, we're going to plug in or evaluate 5 for A, negative 3 for B, and then use that to simplify. So everywhere I see an A, I'm going to plug in a 5. Everywhere I see a B, I'm going to plug in a negative 3. Now notice I did parentheses around this B. Anytime you're plugging in a number for a letter, it's safe to plug in using parentheses. And that's just because if you don't put it, you're just squaring the 3 when you should be squaring the negative 3. From here, we're going to use our PEMDAS to simplify. So I'm going to start with my parentheses. Here, negative 3 is already simplified. Here we need to make negative 3 minus 5 smaller. So negative 3 minus 5 becomes negative 8. Everything else stays the same for now. So notice, parentheses doesn't mean you're doing what is outside. It means you're making whatever's on the inside smaller. Next, we can move on to our exponents. So negative 3 squared means we're doing negative 3 times negative 3, or 9. So this becomes a 9. And I'm going to bring down everything else. From there, we go to multiplication and division. So we're not going to add 5 yet because that's addition. We're going to multiply 9 times negative 8, which is negative 72. And now we can add 5. 5 plus negative 72 is negative 67. If you need a calculator for any individual step, you can use one. You're just not plugging in the whole problem to a calculator. But you could go to your phone or to a calculator online and do 9 times negative 8 and get negative 72, and then add 5 separately. Let's go ahead and look at the next problem here. So for this next problem, we're going to plug in negative 3 for x. Remember, you can use parentheses around your variable to be safe. So this negative stays separate. Then I'm going to plug in parentheses negative 3 for x to the 4th plus 6. And now I'm going to use my PEMDAS to simplify. Now here, you cannot make this 3 positive because you see 2 negatives, because the first negative is separate. If you're using PEMDAS, you would have to get rid of this exponent first. So we're going to do negative 3 to the 4th power, which means we're doing negative 3 times negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is 9. So this really is just 9 times 9, or 81. So this becomes 81. And we still have to bring down that negative that's in front and that plus 6 that's in the end. And then if you add those together, you get negative 75. So this negative right here was separate. So our answer, even though we got positive 81 when we did the exponent, still had that negative in front because it was there in the original problem. Let's continue with some examples that have fractions. So anytime you have a fraction, that just means you're going to divide in the end. So let's go ahead and plug in negative 4 for y. Again, you use parentheses to be safe. So this is negative 4 in parentheses cubed minus 3. And then for w, I'm going to plug in 5. For y, I'm going to plug in the negative 4. Again, I'm using parentheses around my variables. That's because we're really doing like 3 times w times y. If you don't put parentheses, it's going to look like 35 minus 4, which is wrong. On the bottom, we're plugging in for x squared. So we have negative 3 squared minus 2. And for w, we plug in 5. From here, you want to make sure to make your numerator and denominator as small as possible. So the numerator is negative 4 cubed. Let's make that smaller. Negative 4 cubed means we're doing negative 4 times negative 4 times negative 4, which becomes 16 times negative 4, or negative 64. Then I'm going to put this minus, and here we're multiplying all this piece. So 3 times 5 is 15, and 15 times negative 4 equals negative 60. So it's minus negative 60. On the bottom, negative 3 squared means we're doing negative 3 times negative 3, which is 9. Then minus 2 times 5 is 10. Now here, if you look at your numerator, we have minus a negative. Anytime you have minus a negative next to each other and there's no parentheses, you can automatically change that to a plus. So minus negative becomes plus. So it's negative 64 plus 60, which is negative 4. And 9 minus 10 is negative 1. And on your last step, now that you have the numerator and denominator simplified, you would divide. Negative 4 divided by negative 1 is positive 4. this next problem, everywhere we see an x, we're going to plug in -6. Notice this negative here is separate. So I write negative, then I'm going to plug in my x, or my -6, in parentheses, squared, plus 3. On the bottom 2, I'm going to plug in that -6 for x, plus 1. Here, we can't do what we did in the last problem. We can't make these two negatives positive because of that parentheses. This -6 needs to be squared first. So this negative is going to stay separate. And then -6 squared means -6 times -6, or 36. On the bottom, 2 times -6 is -12. Now if we simplify, -36 plus 3 is -33, and -12 plus 1 is -11. At the end, you can divide. -33 divided by -11 is +3. We're going to go ahead and finish up with our last vocabulary and a real-world example. So here, the last thing we're going to talk about are formulas. Formulas are sentences in math that express relationships between different quantities. An example of formulas that you've seen before, like in geometry, are area equals length times width, or perimeter equals 2L plus 2W, 2 lengths plus 2 widths. So those are all examples of formulas you've seen before. And then you can use the length and width to figure out the area or perimeter for those problems. So here in this next example, it says the formula for the number of reams of paper needed to print n copies, so n stands for copies, of a booklet that is p pages, so p stands for pages, long, is r equals np over 500. So here they gave us our formula, and r is the number of reams. So I'm going to go ahead and write down that formula. And it wants to know how many reams of paper you need to buy to print 172 copies. So 172 is our copies. Remember, they said n was the copies of a 25-page booklet. 25 is the pages, so that was the letter P. So I'm just identifying what numbers they gave me for the variables, because now I can plug those in my formula, into my formula to get my answer. So for n, we're going to plug in 172. And for P, we're going to plug in 25. Now, if you have a calculator, you can multiply 172 times 25. That gives 4,300, or 4,300. And then you can divide that by 500. This comes out to 8.6. Anytime you have a real-world problem and you're answering your question, you want to make sure your answer makes sense. So it's saying how many reams of paper must you buy. If you go to a store and buy paper, you're not going to buy 8.6 reams of paper. You would need a whole number. So in order to have enough, you would want to round up. So instead of buying 8, because then you wouldn't have enough, here you would need to buy 9 reams of paper. So usually when you're answering real-world problems, make sure your final answer makes sense, and then answer using words. Those are the notes for the first topic. If you need to, you can look back at these. Look back at this video so that you can help yourself when you're doing the notes. So you would look for questions that are similar and try to check your steps. Thank you.